I'm Anil Kumar, and in this video we will learn how to solve logarithmic equations. So we could start with very basic logarithmic equations. For example, we can have an equation like log to the base 2 of x is equals to 8, and we need to find what the value of x is, right? So such equations could be solved by writing in exponential form. So we could say, well, x could be equals to 2 to the power of 8. So that is the solution of this equation, writing it in exponential form. Similarly, we could have, now always you can use calculator to find the answer, but I'm not getting there. 2 to the power of 10 is 1024, half is 512, and half is 216, right? So that is what you get. Anyway, you could at times use the calculator also. Let's say 2 to the power of 8 is how much? 256, right? So that is how you can find the answer. But we'll kind of stop here. So you can always use calculator and find the answer at this stage. Now this x could be in as a base also. In that case, how do we solve it? So we could have log to the base x, and let's say we have a number 3 here, and we say something, let's say we have number, let's say 2 here. How to solve this kind of an equation? First step is kind of same. We will write this as 3 to the power of x square, right? So writing it in exponential form exactly as we did before. So x is same base, right? So base is x itself. X square is 3. Do you get the idea? Now to find x, x square is 3. So it is square root of 3. That should be equal to x, correct? So you know how. We can actually find a solution to logarithmic equation if sometimes base is not given to us, or sometimes if base is given to us, then how to find. So these are very good examples to understand that part, right? Remember, the square root which you did, you could have done plus and minus, but every log has restrictions, correct? The base has to be greater than 0, right? And the base cannot be 1. So remember that x, the base in this case, should be greater than 0, and x should not be equal to 1. So this is very important to understand. So these are the restrictions which we have to keep in mind when we solve logarithmic equations. Now we could have slightly intricate log equations using some logarithms. For example, I could give you an equation like log x minus 3, and let us say equals to 2. Now if I don't write any base, it means 10 is my base. But I'll apply the same method of solving. I would write this in exponential form. So x minus 3, earlier it was x, now it is x minus 3. So x minus 3 is equals to 10 to the power of 2. 10 to the power of 2, which is 100. So I get my value of x, which is 100 plus 3, or 103, correct? So we can find logarithmic equations, solutions to logarithmic equations like this using this kind of formula, right? You will also observe at times that we may give you equations where two logs are involved. So the equation could be log of, and another bracket, log 2 of x, let us say equal to 1, right? Now that seems to be very complicated, but the method is kind of same. Instead of x, I have log 2 of x here, right? So I'll say log 2 of x is equals to, what is the base here? 10. 10 to the power of 1, which is 10, correct? So we have here. Now at this stage, we need to find x. It is kind of this situation. We'll again apply the same exponential conversion. So we'll say x is equals to 2 to the power of 10. So now 2 to the power of 10, which is 1024, is our answer for this particular equation. So at times there may be applications where you may apply this conversion to exponential couple of times, right? Especially when you have function within function kind of a thing, right? Composite functions. So that is how you should be doing it. Now at times we may have log with square roots. Now those could be tricky. Let me give an example. For example, we could have log, and let me say base 3 square root of x plus 1. And let's say it is equal to, let's say 1. Then what happens? We'll follow the same rule, 3 to the power of 1. So square root of x plus 1, kind of same steps. Instead of x minus 3, square root of x plus 1 is equals to 3 to the power of 1, which is 3, right? Now to find x, we have to square both sides. Remember, whenever you do square, there is a chance of having an error. And whenever you do this, we should write restrictions. X has to be greater than minus 1, correct? Otherwise, within the radical, you will get 0, right? It has to be for log greater than 0, right? So it cannot be. So that is the restriction. Now let's solve. When we square both sides, we get x plus 1 equals to 3 square, which is 9. And so x is equals to 9 minus 1, which is 8. You get 8, you can always test your answer. It is good practice to test your answers, correct? You can test your answer and get the solution. So that is another way of solving this. Now let me share with you one example in which you may not get all the answers as the correct answer. We call them extraneous roots. So the example here is, let's take an example where we have log of x plus 2 and plus log of, we'll apply logarithmic laws here, x minus 1 equals to 1. Now if I have log to the same base, which is 10, plus in between, I can apply the product rule. So I can write this as log of x plus 2 times x minus 1, and this is equal to 1. Now we'll write this in exponential form as we had done here. So in that case, x plus 2 times x minus 1 is equals to 10 to the power of 1, which is 10. So let us expand the left side. It is a quadratic equation, and then solve that quadratic equation. So we get x squared minus x plus 2x minus 2 equals to 10. Bringing 10 to the left side and solving, we get x squared minus and plus 2x makes it x, minus 2 and 10 when you take away, minus 12 equals to 0. And this I can factor as 4 minus 3, right? 12. So x plus 4 times x minus 3 equals to 0. Now this equation gives us two possible solutions. I am saying possible solutions. Let me highlight it here. I am saying possible solutions because both may not be correct. First one is x equals to minus 4. That will give us this 0. The other one is x equals to 3, correct? So these are the two solutions. So here, when will it be 0? At x equals to minus 4. This will be 0 at x equals to 3. As you can clearly see, if I write minus 4 here, then I get a negative number inside. So that is not permitted. Is that okay? So we call this as extraneous root. So this is called extraneous root. So it is not the correct answer. However, 3 is correct. If I write 3 here, 3 plus 2 is 5, 3 minus 1 is 2. And if you evaluate, you will get 1 using this particular equation, correct? So we can now write down that one of the answers is correct, and our solution to this equation is x equals to 3. So I hope with this video you get gist of solving logarithmic equations. I'll provide you with few links which will help you to explore and practice each kind of equation to be solved. And I hope that prepares you well for your test. Thank you and all the best.